Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about fancy launch systems. So let's dive right into it. Now, what exactly is the issue that we have to go into fancy launch systems? Well, reality is rockets are huge. Now, most people have no understanding of how huge rockets are simply because whenever you see a rocket, they are surrounded by things that do not make sense. Meaning, you do not have a office building next to it, so you get the idea. Oh, this is a freaking skyscraper. So that's why most people have no understanding of how huge Saturn V is, or how huge space shuttle is, or how tall Falcon 9 is. So it's one of those things that most people don't understand, but it's huge. Meaning, for any Tom, Dick, and Harry who's building this thing is gonna cost a lot of money, and that's another problem. They are expensive AF, meaning it's not something that any country can afford. It's to give you a context, there are around 200 countries, only few countries that have a actual tangible space program, and even huge names do not have a good system. So to give you a real understanding, just figure out how many European nation have their own space program. Very few, and very few have actual launch capabilities, and same with Australia. So it's expensive and big, and every Tom, Dick, and Harry, be it a small country, be it huge country, be it poor country, be it rich country, wants cheaper access to space. Meaning, once you can access space, you can do things. For example, in terms of communication, it's awesome if you can do that. For example, if Starlink's system works properly, then you are talking about a global planet-wide satellite coverage, which no other system can match. The only reason SpaceX can even attempt to do something like that without going bankrupt is simply because they have amazing rocket known as Falcon 9. No other people can even attempt, simply because none of them have any rockets. And that's the same thing happened with OneWeb. OneWeb was working before Starlink started to come online. They launched satellite and then they went bankrupt. Other companies have bought it and they are trying to scale it down, trying to make it work somehow, but good luck to them. And rocket industry is very hard to get in, meaning not just any Tom, Dick, and Harry is okay, I'm gonna make a rocket and launch this puppy to space. Just a sheer political side of things that you have to deal through, meaning the licenses, laws, regulatory bodies, and all that jazz. That alone will cost boatload of money. After that, because of the size and complexity of these things, it's expensive. It's so expensive that you will have better luck making a supercar company and then surviving. So only few players have succeeded. Many have tried. Now be very mindful, many people have tried, many companies have tried, but majority of them faded out. So what are these fancy options? Now these fancy options, the one of the highest fancy option is single stage to orbit, meaning another aspect of rocket that makes them so expensive is they are use and throw. Even something like Falcon 9, they have very high level of use and throw, simply because the whole second stage poofed out of existence. So people all from day one knew that if we are throwing these things away in space, it will inherently make them more expensive. But if we made a system that is literally like an aircraft, it takes off from a launch pad or a runway, whatever have you, it takes off, then it goes to space, then it lands, it will save boatload of money. Yes, the product cost will go up, but because of the reusability, because of the simpler nature, and the fact that you are not throwing fairings away, you are not throwing second stage away, it will save them boatload of money. So that is single stage to orbit. Then you have balloon launch, because weather balloons can go very high up, meaning upwards of 10 to 20 kilometers up. So they can go far up, and benefit of going that far up is at that point in time you are almost in vacuum, meaning your engines have to be optimized only for one level, which is vacuum optimized. No, they no longer need to deal with sea level optimization, which saves them gives them a bit of efficiency, and the fact that they are not fighting with atmosphere. Then you have air launch. This is getting a lot of attention in recent years, and the whole point of all these three options is basically they're gonna provide lower cost entry, meaning you can do it, maybe you able to afford it, and they're gonna provide very high cadence. Cadence is another aspect of it, because many things in rocket industries are fixed. For example, let's say you bought a license for a launch tower. That license would be in based of terms. It generally won't be in okay, you can launch 10 rockets. It will be for 1 year you have this puppy, so you want to milk that puppy, you want to get as much out of it. That simply means you need to have high cadence, and rocket industry generally have very poor cadence, meaning even huge companies like SpaceX do not have 500 launches per month. We have more than that per aircraft wise. So as in 1 month you can easily have more than 500 aircrafts taking off. Duh, that's a basic common airport. So we do not have very high cadence. All these systems are trying to give high cadence and low cost, so it becomes more profitable, more affordable. That's the idea behind it anyway. So let's look at the most sexy option, that is single stage to orbit, meaning that's what we want at the other end. It's like it's just a something, like how you see in Star Wars, you just get into a thing and it goes to space. And again, it's even got here in Star Wars simply because it can go from galaxy to galaxy. But that's another story. But right now, the main aim is basically no staging. You will not have stage 1, stage 2, stage 3, and you will not be throwing things away. Basically, fairings, stage 2, stage 1 in most companies, you will not be throwing, and it will not be disposable. By design, from day one, it will be built in such a way that everything is reused and serviced and launched again. So that's the whole point. However, there is something known as gravity in our planet, which is way too goddamn deep. Meaning, the velocity you need to break this puppy, it's heavy. Meaning, we can easily do this on Moon. To give you a context, we have already done this into the Moon. So it's one of those things that's super easy to do on Mars. Bit of difficulty, but we can easily do that. But Earth, minus 9.8 meter per second squared. Yeah, good luck with that. And primary reason we cannot do that is basically we do not have any fuel. You may think RP1 is very powerful. It has like a lot of carbon molecules, so it has like oomph, that heavy oomph that you need. Like that's why Saturn V used it in stage 1. However, there is a problem. Like while you may need only this much kerosene, you will need this much liquid oxygen in order to burn this puppy. So that's the main problem. Like, and you may have like hydrogen. You've got like, for example, space shuttle. It has like huge hydrogen tank and tiny oxygen tank. At the end of the day, that's the main problem. We do not have any liquid fuels that are super awesome. And you may be like, what about solid? While solid does have some benefits, specifically being it gives you ludicrously high G forces. I mean, you can launch something that can achieve 100 Gs. Other than that, it has no oomph. Like it, and be mindful, if you are talking about human launching into space, you want to be like under 5 Gs, and that also for very short spikes. You do not want to be like at 5 G continuously. It's not expanse. So that's the reality of the Earth's gravity well is too goddamn deep, and our fuel systems are too weak. But more than enough people have poured more than enough money. Like this puppy was being developed literally after space shuttle was built, and people figured out, yeah, it's not working. This was another project that was like greenlit, as in like a small scale, 1/5 scale physical prototype that's supposed to fly, supposed to go to orbit, was built up to 95%, meaning they were about to launch this puppy. But they realized kind of like there were many things there, like it's almost works, but it was not good enough. The R&D they spent on this puppy was huge, so they realized it's like let's cancel it. It was like almost complete, but it was like, yeah, once we have done it, once we have started to mass produce, then we started to yeah, it's not cheap. So that's why like they abandoned this puppy. And other company like Skylon, they have been working for decades at this point in time. They have built this engine. Now this engine uses hydrogen. Now hydrogen is not very efficient, but it does have the advantage of being very cold, meaning they can utilize the cold aspect basically of liquid nitrogen to run a helium circuitry. That helium circuitry will basically condense the atmosphere. When the engine is going through the atmosphere, it's going to condense the atmosphere, give you liquid oxygen to burn. So that way you can get more oomph out of it, and it will also utilize the cold of that system. Now this engine has been physically built and physically tested. However, nobody has ever went, like, again, the company also, I'm pretty sure, went bankrupt multiple times, as in like one owner bought it, then another owner bought it, then it's like changing hand multiple times. It's too goddamn high. The R&D cost of developing any sort of system that is like single stage to orbit is too high. Consequence of that is their cost competitiveness is zero, meaning the probability of any of these systems comparing to, let's say, Starship or Falcon 9, yeah, zero, or even Neutron rocket is zero. And even though it costs a lot of money, it basically sends very huge rockets with very small payload. For example, the same payload capacity space shuttle had, this puppy is supposed to have Skylon. However, space shuttle was only 37 meter long, which is like still huge, but basically Skylon would be 83 meters. To let that sink in, it's almost touching like 90 meters kind of size. That's huge, as in freaking huge. So that's why, and when you are building something this big, size directly limits where can you build this, where you can transport this puppy. And because this puppy will be Mach speed on runway, let that sink in, Mach speed on runway, it needs military grade, high research grade runways, meaning the runway has to be much longer, meaning rather than, let's say, 1 or 2 kilometers, it has to be 5 kilometers, and it has to be flat. Like, wait a minute, isn't runways are flat? Well, no, most runways are not, especially if they have been used by any commercial entity, meaning you will notice that, especially if you look at a telephoto lens from front end, you will find like there is a dip there wherever the airplanes are landing. Again, for aeroplane point of view, it's okay because it's barely doing 300 to 500 kmph, but when you're doing Mach speed, that's a no-go, no bueno. So huge aircrafts or rockets or whatever have you, and the ground infrastructure requirements are even huge. So reality is, it's one of those things that we cannot do this. Like realistically, from a financial point of view, engineering can do that. Science is like, yeah, you can do that. Again, these are the sort of system, this was done mathematically, meaning it's not just like, oh, somebody making a Kerbal space program. It's an actual NASA project with almost guaranteed working. But the reality was like cost was the main issue. It's like, yeah, we built it, it's just cost $1 trillion to launch. Who the hell is gonna do that? Same with Skylon. Skylon is a known thing, like with the actual mathematics done to it, so it should work. It's just like cost of these engines are huge. Let that sink in. It's somehow at Mach speed, it basically liquefies air and gives oxygen to the engines. Let that sink in. That puppy works. So good luck with that. So that's the reality of it. That's why SSTO likelihood of that working is almost zero, simply because of economics. Then we come to something lighter, that is Rockoon options, meaning the idea of weather balloons is that they go very high up, meaning weather balloon can easily reach a point of 10 kilometers, 20 kilometers, or sometimes as high as 21 kilometers per. So if you are at that high up, meaning you are almost at partial vacuum, meaning only vacuum optimized engine, and even when your rocket is accelerating, it's not fighting with the atmosphere. Atmosphere is a big issue. That's why we utilize fairing covers. Otherwise we will not need fairing covers, and fairing has to go through literal shock waves. Like you can notice that, like if you are watching rocket and the weather is good, you will literally see shock diamonds being created. So those are some serious issues. But when you are like that high up, even though you will accelerate like crazy, you will not have to deal with shock waves of the atmosphere. That's awesome. You are already high up, meaning your nozzles are optimized. You do not have to fight with your atmosphere. So fairing could be just like a cloth symbol, just to make sure that when you're going up, if rain started to happen, it's not gonna damage your equipment, just for safety. But it has the issue that it really can't be used for large payload, meaning balloons have that inherent limitation, meaning they work most efficient at like medium altitude, meaning around 10,000 meters or something like that. Because once you start to go up, most of the atmosphere is below you, meaning what is pushing you up? Answer is nothing. That's why like there is a maximum limit it can go. It does not matter whether you fill it with helium or hydrogen. There is an upper limit to it. You cannot go beyond a certain point. And when you are carrying something heavy, that limit starts to come down, meaning you cannot even achieve very high altitudes. At that point in time, the total payload that you have to carry becomes an issue, meaning your rocket cannot be huge. And then the total payload that is going to the orbit goes even smaller, meaning you will be very lucky if you can even achieve 10 kilogram to low Earth orbit. That's very limited. That's why many companies have tried. Again, at this point in time, 10 kilogram is a lot, meaning our electronics are compact enough, small enough, and solar cells efficient enough that you can do a lot in 10 kilograms, but it's really not that useful. And at the end of the day, you still need a multi-stage rocket. Then what's the point? Meaning this was a design from a rocket company where there's like they had ring rockets. One rocket will fire, then from inside that there will be another ring, from inside that there will be another ring. That's why like it does not have a vertical stack, it just have a like parallel stack. Consequence of that, like if you're doing that anyway, and majority of the delta V and height will come from the rockets itself, why not just make that puppy a bit bigger and launch it from the ground, and you solve all the issues? It's like you do not have to worry about the size and weight limitation. That's why this puppy never like actually pick up any steam. Like you will barely see one or two of them. And again, it does work for very good for sounding rocket. You can take sounding rocket that are like good, and you can make them almost orbital class. And if you are doing very cheap instrumentation, very cheap experimental data, people have used this puppy, but it's not something that you can see in the future where it's going to do some heavy launches. It's not going to work. Physics does not allow it. Atmosphere does not allow you to carry like something like Saturn V. And if you're going to build a multi-stage rocket anyway, why not just launch it from goddamn surface, and then you have size restriction removed, then you can make it as big as it's needed. So that's why this also does not work. Economics. And then we come to air launch. Air launch puppy right now is getting a lot of attention from like this old design to new design to Virgin Galactic. And reality is, what they want to do is basically have a jumbo jet, and it's going to give the height, meaning it's going to give them 10 kilometers around. It cannot go very high up as in like weather balloon, but it's going to also give them some speed. Like weather balloon, from a point of view of a rocket, it's like almost standing still, but this puppy can easily give them like around 300 kmph, because again, the moment you drop, it starts to slow down. So it can give them some inertia. And whenever you're talking about inertia, zero is bad. Like anything, if you're moving, it's easier. Like that's why it's much easier to start a car as in accelerate a car from 10 kilometers to 50 kilometers versus 0 to 10, because 0 to 10 it has to fight the inertia. It's like very big. And you will notice that in dragster, like most of the energy goes into just to accelerate the car. So that's the same thing with rocket. If rocket is already in transit, it does give them a good boost, so to say. But every Tom, Dick and Harry kind of forgot, like jumbo jets are not cheap, and to be realistic, they are far more expensive than rockets, because jumbo jets are multi-use vehicle, meaning they're not going to be like you launch it and poof, It's not rocket. Rockets are designed to be costed down, like barely anything on it. It's like fuel tank, turbo pump, fuel injector, nozzle, done, go home, sweet dreams. And again, avionics and control logics and all that jazz, but nothing fancy. Aeroplane have multiple layers of equipment, which means they have ludicrously high cost, and maintenance of these puppies are not cheap. Ask anyone who has to maintain, basically have a fleet of let's say Boeing 747. It's expensive. And if you're talking about even bigger than this, like for example something as big as Airbus A380, yeah, good luck with that. It's expensive, and you can easily see this work out in real life when we are talking about last year's basically space race. Many people try, like, Virgin Galactic system. Again, you may think, oh, it's super easy, they just have to deal with a plane and they just have to deal with a smaller rocket and like done. But reality is, how the heck Blue Origin beat them to basically orbit? Now you're like, not orbit as an orbital height, again, because it was a simple system. It was a single stage, went up, done, go home, sweet dreams. This was a plane they had to maintain and develop, and then they do have to other system that has to launch and file a rocket. So you have multiple equipments to deal with. Maintenance cost goes up, the part count goes up simply, and the part count directly translates to cost, total system cost. And this inherently has a limitation. It also cannot carry heavy loads, because you may think, oh, jumbo jets, but here's the, yes, it can carry like few 100 tons. That's not a lot. Like that amount of propulsion is like nothing, not huge. That's like okay, that's like Electron rocket kind of size. That's not Saturn 5. That's like okay, Electron rocket kind of size. And to be fair, actually smaller than that. So, and again, they had to strip down everything inside the plane to make it that light and capable, because again, they are not built for carrying this. And there are some straddle launch craft that is built for this. Again, it's idiotically expensive, and even at full capacity, it cannot actually carry something very huge. It's like, do not expect it to carry like something like SLS. It simply cannot. Physics does not allow it to, and that's the whole point. So are they good for anything? Yes, they are very good for anti-satellite weapon systems, meaning every country is developing this sort of system simply because they can knock out other opponents' satellite or their own satellite. If their satellite is becoming an issue to space environment, they can do that. That's awesome aspect of it. But other than that, it's really only limited to small satellites. And when you look at the overall picture, you're like, yeah, I figured out why the Electron labs are making a rocket lab is making so much progress, because again, it's a simple system. They have to build rockets. Same thing here. If like you have to build this damn thing, how about you make the diameter a little bit bigger and you stand this puppy up? Done. Go home, sweet dreams. So that's the whole point. That's why every company that is trying to do this sort of system always falling back to the same thing. It's like, this aeroplane, yeah, it's aeroplane. Yes, you can buy it. But it's not like, it's a cheap thing. Oh, here's my, basic credit card, just swap it. I don't even think you can buy these things on debit card. You need very powerful credit cards for that. So that's the reality of it. That's why air launch also does not work in grand scheme of things. Yes, you can make it. Yes, you can launch from this. But at the end of the day, companies like Electron or even Astra or even Firefly will generally slap you, simply because they are much simpler operation, means their cost of operation, running of the system over a year would be much lower. So even company like Virgin Galactic, which has like a big financial backing, they're like not doing too well. And again, I'm hopeful at the end of the year they will have at least one more launch, and by that time I'm pretty sure Blue Origin would have done 5 or 6 more launches. So you get the point. Like, rockets are inherently simpler, and if you have to put rocket on top of anything else, it's like, dude, just make the rocket bigger. Just like, don't do extra steps. Like, extra steps are the worst, meaning engineering's first rule: complexity is the enemy of reliability. And budget also. So that's why this system will also not work for long term, meaning especially you cannot expect in future we're gonna launch air launch stuff for space station build. Yeah, that's not happening. So this was my presentation on fancy launch options. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.